Hello everyone, this is Dr. E, and for today we're going to be working on points, lines, and planes in geometry. I often mention that learning mathematics is like learning a foreign language. You need to know how to read it, you need to know how to speak it, so that you'll be able to understand each other, and that's what we're going to be working on in our lesson in geometry today. And let's start with some of the undefined terms that we're going to define in our lesson today. The first one is a point. By definition, a point has no dimension, no length, width, or height. And it does have a location or position, and that's how we define point in geometry. So how do we name it? Again, it's extremely important that we know the symbols that we are using in some of these undefined terms so that we'll be able to understand geometry better. And to name a point, it's pretty simple. You just need to use a capital letter. So to name a point, a single capital letter is enough. Not two, not three, but just a single letter like this. So point A in this case is denoted by the capital letter A, and it's read as point A. So that means if we have another point, this point right here, we can name this as point Z if you want to, and we'll call it as point Z in geometry. And notice that in geometry, we cannot use the lowercase letter, so we cannot name this point as point M because this will defy the rule of naming a point in geometry. So instead, we'll use the capital letter so that we will be able to understand each other without confusion when it comes to mathematics, which as we know is an exact science. So let's now define a line, which is another undefined terms in geometry. So a line, in this case, extends in opposite direction without end and has one dimension, and that is the length. So how do we name line in geometry? So if we use single capital letter for a point, for a line, we'll be using two capital letters. So name a line by a single lowercase letter or by any 2 points on the line are the two ways on how we name a line. So how do we use a lowercase letter for a line? So let's say this is a line. So we can name this line as line L, and notice that I use the lowercase l because this is how we name a line in geometry. And another way of naming it is picking 2 points that lie on this line. So we can say that this is line A and line B. So another way of naming line L would be line A, B. But there is a special symbol that we use, and that is a line with two arrows on the opposite direction for A and B. And if we have two ways of naming this line right here, there is another or third way on how we can name this line, and we can name this line as line BA. So in geometry, when it comes to notations, we can interchange the 2 points or two capital letters and they will mean the same description. So that's how we name a line in geometry. We need 2 points, and in this case, we have points A and B on the same line. So we can name it 3 ways. One, line L or line AB, or we can also name it as line BA. And we have planes in geometry, so we have points, lines, and planes, and a plane in geometry extends in 2 dimensions. Now we're talking about 2 dimensions without end. So the 2 dimensions are length and width, but no thickness. And we represent a plane by a flat surface. And when we are naming a plane, we can name it also in several ways. For example, we name a plane by a single capital letter or by any 3. That means we're using 3 letters this time, capital letters, not 1, not 2, not 4, but only 3 to denote a plane. So let's say we have this plane right here that you are seeing right now. We can name this as plane P or plane A, B, C. So this is how we use plane, and notice that A, B, C are not on the same line because that's another rule that we need to take note of, because it's not just 3 points on a plane. Those points cannot be lying on the same line. So now that we know how to use symbols to represent points, lines, and planes, let's see if we can identify these points, lines, and planes in this figure that we are seeing right now. The first one is to write two other ways to name line QT. So line QT is denoted by this line right here, and we know that we can simply represent line QT as the easiest one. We can name it as TQ, and the other one, we can name this as line small letter m. And this is how we denote a line, and we know that we're able to produce those two notations using this instruction. And now on the second one, let's write two other ways to name plane P. And for naming a plane, if we are seeing a plane right here, we can name it as, we need to use three letters, and they are not on the same line. So one of them would be plane RQV, another one would be plane RSV, and another one would be plane QSV. And notice that we did not name RQS because RQS is on the same line. So even though we have three letters here, we cannot represent the plane as plane RQS because we might get confused if we are referring to a line or a plane if we use those three letters. So in geometry, we need to make sure that we follow the instructions similar to how we write symbols like what we're doing here right now. And if we're going to be naming 3 points that are collinear from the words co and line, it means co means together, and linear, it needs to be on a line. So that means one or a group of points that's on the same line in this particular plane would be this one right here, which is pretty obvious. So we can have those 3 points as 3 collinear points because they are on the same line. And we cannot use RQV because RQV, even though there are 3 capital letters there, but they're not lying on the same line. And for the last one, let's name 4 points that are coplanar. And coplanar, it's on the same plane. And those 4 points that we can use would be R, Q, S, and V. So even though R, Q, S are on the same line, we are seeing that V is not on the same line. So we can use those 4 points as points that are coplanar because it's on the same plane. So this is how we describe points, lines, and planes in geometry. And now that we have these undefined terms, let's define more. And we'll start with space. Space is a set of all points in 3 dimensions, and a geometric figure is any non-empty subset of space. Now, we use the term between when points are on the same line or line segment to avoid confusion when we are describing points that lie on the same line. So for example, we are seeing 2 figures. We have a line and a plane. And if we're going to be describing point B on the first figure, we can describe B as point B is between points A and D. So it's in between those points. So notice that I use the word between so that I would know that they lie on the same line. Another way of describing B in this case would be point B is between A and C. So we are now going to move that point to C, and this will be our description for point B. And for the second figure, we're not going to be using B in between 2 points because obviously it's not. So we're just going to describe point B as a point that's not in between A and C. So notice that the word that we are using is extremely important when we are working with geometry, like what we are doing here in this example. Another undefined terms that we're going to be using is line segment. And what's the difference between a line and a line segment? A line segment, or simply segment, is part of a line. So it consists of two endpoints and all the points between them. So how do we name line segment this time? We're naming it using two letters, just like a line, but in this case, notice that there's no more arrows on top of our line because this is how we denote or how we use symbols in geometry, so we know that we are seeing a line segment and not a line. So this is line segment AB or line segment BA. So if we have a line, two endpoints, MS, this is a line segment because we are seeing two endpoints here, and to write it out using the correct notation, we can write it out as MS. This is line segment MS, MS, or SM. So you're not seeing it, but here, SM. So there, SM or MS, they are the same, and that's how we denote line segment in geometry. So in this case, we have line segment AB. So if we draw or illustrate this description, we'll be able to create these illustrations and notations for line segment AB or line segment BA. Another terms that we're going to be identifying is array. Array is part of a line, and it consists of an endpoint and all points on a line on one side of the endpoint. Can be a little bit confusing because of all the words, but it's simply a line with an endpoint and an arrow. So we name array by its endpoint and any other point on the array. Now, the difference between array and a line is that you cannot interchange the letters here this time because one of the letter represents the endpoint and the other one represents the non-terminating line. And that is how we use array AB in this notation. And to describe array AB, there are 2 points, A and point B, but since we are seeing array AB in this notation, that means illustration-wise, this is how we draw it. So this is ray AB, and we know that ray AB is not the same as ray BA. Why is it not the same as ray BA? Because ray BA, if this is A and B, this is point A and point B. B is our endpoint and A holds the arrow right here. That's why they are not the same because their directions are different. So if we have ray AB, which is denoted by this notation, ray BA has another notation and illustrates a different direction. So that's a difference between array and line segment. The order of those letters are important. And then we also have opposite rays, and opposite rays, from the name itself, we have a line, and we can partition that line because we have a point that is common to those rays. So opposite rays are two rays that share the same endpoint and form a line. And this is how we name or illustrate opposite rays. We'll see a line and a point in between. So we can have point CB and point CA. We'll have ray CB and ray CA, and we can describe this as opposite rays because they share the same point, which is point C. So that is how we illustrate and use symbols for these geometric terminologies that we often use in mathematics. So with that, since geometry is similar to learning a foreign language, even though we're seeing symbols here, we'll be able to produce this as what is instructed in this steps by just following those symbols. So we need to perform parts A through D and create a single figure using those symbols. So let's try it in our board right here. So the first instruction is to draw three non-collinear points, M and L. Non-collinear, not on the same line. So this is M, N, and L, and they are non-collinear points. The next instruction is to draw line MN, and line MN holds point M and points N, and it's a line, so we have arrows in between them. The third instruction is line segment NL. This is point N and this is point L, and those are the endpoints, and this is our NL. And ray LM, and we know that in rays we have the endpoint, which is L, and the line M. So this is how we draw this figure according to the instructions. So let's see if this is how the figure should look like based on this instruction. Three non-collinear points, M and L, and then line MN. So we will connect MN and make sure that we are using the correct illustration. Line segment NL, the endpoints are at N and L. So this is how we draw line segment NL, and then ray LM is denoted by the endpoint L all the way to M. So this is now the figure that is similar to what we're able to produce a little while ago. So once again, to be able to understand codes in geometry, we need to understand what it means so that we'll be able to execute it correctly. So now let's work on postulates. And postulates are we know postulates are accepted truths, specifically in the subject of geometry. And the first postulate that we are going to be working on is the 2 points determine a line postulate, which means through any 2 points, there is exactly one line, and line T passes through points A and B. Line T is the only line that passes through both points. So how do we illustrate this postulate? So if we have 2 points, point A and point B, 2 points determine a line. So if we connect this line right here, we are seeing that point A and point B is contained to line T, and this is basically what the postulate is describing us. So if we have 2 points, those 2 points will always be contained inside a line, and in this case we named it as line T. So point A and point B, if we connect this, we'll have this line right here, which is line T in this particular postulate. So if we have a postulate for 2 points, we also have a postulate for intersecting lines, and the intersection of lines postulate states that if two distinct lines intersect, then they intersect at exactly 1 point. So if we're going to be using this point right here, so we already have a line, we need another distinct line. So let's say this is point M and this is point N, and if we connect this, we produce a line MN, and their intersection is right here, and we will only have one point of intersection for this particular description, and this is what basically the postulate is telling us. So let's name this as point Q. So this is what intersection of line postulate describe. So if we have two distinct lines, let's say AB and DE, it intersects at point CE. So point AB, connected, we have a line. Point DE, connected, we have another distinct line, and their intersection is C, or point C, and this is basically how we describe this postulate. And if we can intersect line, we can produce a point when we intersect a line. We can also produce another set of figures when we work with planes. So let's say we have plane RST and plane WST. If we intersect those two planes, we'll be able to produce a line this time. And this is line ST. And how are we going to illustrate this description? Let's have the first plane, RST, and the second plane intersecting this would be WST. And their point of intersection our point S and T, and those points describe the intersection of the two planes that we have right here. So this is how we illustrate this postulate on two planes, and when two planes intersect, remember that it produces a line. So now that we know those postulates, let's see if we can identify non-collinear points or this postulate about non-collinear points. So in this postulate, through any three non-collinear points, there is exactly one plane. The operative word here is non-collinear, which means they cannot be on the same line, so that we can denote a plane. So this is an example of plane P that contains QRS, or points that are non-collinear, and we can describe this as plane RQS, as described by the three non-collinear points determine a plane postulate. So now that we have those postulates, let's see if we can identify what is being asked in this instruction. So according to this, each surface of the box shown, like what we are seeing, represents part of a plane. What is the intersection of plane ADC and plane BFG? So the first thing that we need to do is to identify plane ADC, which is denoted by this plane, and plane BFG, which is on this side of the box. And the point of intersection of those two planes, as we know, is a line, and that would be line BC. So the plane intersect at line BC in this particular figure, and we're able to describe it because we are understanding the symbols that we are seeing in this illustration. And another thing that we can do is to determine those points in this particular plane. So now we're seeing a cube, and we need to shade the plane that contains point NPQ, and by just looking at the cube, we know that N, P, and Q are there, and if we find that plane, it's associated with this plane right here, which is the bottom part of the cube. So now we know where those points lie, and those points are in that particular plane. So the plane on the bottom of the figure contains NPQ, and we can name that plane as plane RNQ, or plane QPN, or plane RNP. So that's how we are able to describe this illustration by understanding the symbols that we have learned in geometry. And with that, the Numberbender challenge for the day is: what is the intersection of plane AEH and plane EFG given this figure? And I'm sure you'll be able to identify that easily. So comment it down below, and let's see if you can describe what is being asked in this question. And that is our lesson on geometry. It's all about lines, planes, points, and postulates that we are using to be able to understand, again, the language of mathematics. Because learning mathematics is like learning a foreign language. If we know how to read it, if we know how to say it, then we'll be able to understand each other, just like what we're doing in learning mathematics. This is Dr. E, and see you again next time. Bye!